All right, so for this one, we're going to be talking about graphs so that you are able to read the graph radioactivity and you. So let's look at how to do this. There are a variety of informations that we can convey in different charts and graphs. So let's look at a few of these examples. This one here, I think everybody is familiar with the pie graph. A pie graph is going to show you percentages out of 100. So if we look at the slices that have been eaten, we have slightly more than a quarter. So I would call this, if I were rough estimating, I would call it between 18 and 20%, leaving 75 to 73%, depending upon how you want to call it, left to be eaten. This person here has decided that this is the section of pie they have eaten, and this is the section of pie they are going to eat but have not yet eaten. So, yummy. All right. But depending upon who's making the chart and what they want to try to convince you of, they can give you some misleading information. For instance, this person here has put together two pieces of information that have no connection, but you could make a compelling argument using them. This red line here shows the change of temperature over time, the average temperature. This blue chart line here shows the percentage or population of pirates. So what we see according to this chart is that the population of pirates has steadily declined while the changing temperature has steadily increased. So if we wanted to, we could make the argument just based on this chart right here that the decline in pirates has caused the average global temperature to rise. We could also try to claim that as the temperatures have been rising, they have killed off the population of pirates. Now, hopefully, there are lots of reasons why piracy has gone out of vogue, at least here in the western part of the world. But none of them have to do with temperature. They all have to do with policing and military and population and stuff like that. So you got to be careful. Now, this is a line graph. A line graph, this is accurate, should show change over time, among other things. Change over pressure would also be okay, but we're looking at the same stuff. We're looking at temperature and how it changes, in this case, over time. We could be looking at temperature and marking how it changes over elevation, so sea level versus the top of a mountain. But we're looking at how something changes. And then we have our final example here. This is a straight up bar graph. We're just plotting numbers and allowing us to compare them. So this graph right here is showing where people's ancestors came from. What were the most common origins of U.S. residents based on the 2000 census. So we can see that we have a large number of people that came from England, but a larger number of people whose ancestors came from Germany, Portuguese, Irish. We've got a Slovakian contingent here. We've got Norwegian and Polish. So we have all kinds of ancestors represented here in this country, and we can just compare rough numbers. And pay attention over here. This axis is going to tell us what those numbers mean. All right, so when you look at a graph, what you need to figure out is what kind of graph is it, first of all. And then you need to figure out what are the variables, the dependent and independent variables. Think back to Unit 1, and we talked about that. An independent variable is going to be plotted on the x-axis. That's the axis that runs like this. A dependent variable is going to run on the y-axis, which is the one that runs up and down on the line. Sometimes we see more than two variables. For instance, if we look back here at our pirates, we see climate change, the change of temperature. We see time and, crazy amounts, we see the total population of pirates. So depending upon what we're looking at, what kind of graph we're looking at, we might have a lot of information to process. So then we want to look and see what the units are. We're talking about numbers of people. That's what we're going to see on that y-axis, the one that runs up and down like this. Are we looking at meters? Are we looking at temperature? Are we looking at radiation units? Kilograms? What are we looking at? So that we can interpret those numbers. And then what is the scale? So for instance, does every line or every box represent one? Or as in the case of the pirate graph, does it represent millions? Sorry, the US bar graph represents millions. So we want to see what each of those chunks is representing. How many are they representing? Now, this is the graph that you're going to be using. Make sure you have that handy, and then we'll talk about it. Now, you're going to use this graph right here. I made it a little bit bigger, so I cut some of it out. You're going to use this graph here to complete the answer key, the answer sheet. So the first thing we need to figure out, again, is what kind of a graph are we looking at here? So this one is going to most closely resemble a bar graph because we're showing total numbers of something. But we have so much more information than we could put in a bar graph that they've created a slightly different format for it. To interpret this whole area here, the blue section, is represented comparative to all these green sections in this little tiny space right here. Now we're talking about the amount of a dose of radiation from exposure to the things, and it's called a sievert. And in this case, it gets abbreviated as SV, and this is a microsievert. So it's a very small amount of dose. So we can see that there are lots of different actions that occur in our world that expose us to little tiny bits of radiation. This small amount over here is not going to be something that shows up in your body. For instance, this right here, this green amount, which is 5 times or 6 times the amount of the total amount of the blue radiation. This is just what you get, the dose that you get from exposure to the natural potassium in your body. That's not a harmful amount. And it's more, if you pay attention, you can see it's more than is released from a limited exposure to nuclear power plant, like living in a neighborhood that has one or living in an area that has one. So we can see different amounts, and we start to see where the amounts are where we, as humans, would have an exposure or a chemical reaction or sickness as a result. So you want to use this chart to answer the questions on that worksheet. You don't need to write on this. All the information's on there, looking at the small print right here. And then also, if you're not sure how to read this still, read this section up here, and it will tell you how further to read this chart if you're not sure yet. All right, good luck.